Okay, so let's take a look at your homework from yesterday. I asked you to do on page 331, 22 to 40 even. So for number 22, question's asking you what angle gives you an inverse sine of 1 over root 2. And I know that comes from my 45, 45, 90 triangle. So this is a positive number, so I'm going to draw 45 degrees in the quadrants where sine is positive. So therefore x would be 45 degrees, and x would be 180 minus 45 is 135. For number 24, it's asking you what angle gives you an inverse secant of 2. Another way to think about this is what angle gives you an inverse cosine of 1 over 2. Well, I know that happens from our 30, 60, 90 triangle, and that's going to happen at 60 degrees. We would have, let's say, 1, 2, and root 3. So the secant would be 2 over 1. Because this is a positive number, we're also going to draw wherever secant is positive, which is right here. So one answer would be 60 degrees, and one answer would be 360 minus 60, or 300 degrees. Number 26 says what angle gives us a sine of 1/2. Well, I know from the last problem we did, that's going to be a 30, 60, 90 triangle. And because 1/2 is positive, I'm going to draw this triangle in the quadrants where sine is positive. And the sine of 30 degrees would give us 1/2. So my answer is going to be 30 degrees, and 180 minus the 30 is 150 degrees. Number 28. It says x is the inverse sine of negative 1/2. Well, we just saw in the last problem that 30 degrees would give us a positive 1/2. So because it's negative, we don't want to draw our triangles where sine would be positive. If we draw 30 degrees in these quadrants, we would get a negative sine, or a negative 1/2. This angle would be 180 plus 30, and this angle would be 360 minus 30. Number 30 is saying, what's the sine of the inverse sine of 1/2? Well, I'm sure you guys like that problem. The answer is just 1/2. Number 32, it's asking you what's the sine of the inverse cosine of root 3 over 2. And, well, we have to figure out what angle gives us a cosine of root 3 over 2. And that's going to come from our 30, 60, 90 triangle. And the cosine of 30 is going to give us a cosine of root 3 over 2. So that just turns into 30 degrees. And the sine of 30 is 1/2. Number 34, it says what's the cosine of the inverse cotangent of 4/3? Okay, well, let's draw this triangle. I'm going to draw a triangle whose angle, whatever that angle is, the cotangent of that angle is 4/3. So using Pythagorean theorem, we'll get 5 there. So this angle turns into this angle right here. The cotangent of that angle is 4/3. So what's the cosine of that angle? The cosine of that angle is 4/5. It's a little bit different, but same idea. Number 36, it's asking us what's the sine of the inverse tangent of root 3 plus the inverse cotangent of root 3. Well, in order to get root 3, that's going to come from our 30, 60, 90 triangle of 1, 2, and root 3. Now the tangent of 60 degrees would be root 3. The cotangent of 30 degrees would be root 3. So the sine of 90 degrees is just a quadrantal angle. The sine of that angle right there would be 1. Number 38, it's asking you to find the tangent of the inverse sine of root 2 over 2 minus the cotangent of the inverse cosine of root 2 over 2. Let's do this piece by piece. What angle gives us a sine of root 2 over 2? Well, I remember our 45, 45, 90 triangle gives us a sine of root 2 over 2. So this is just going to be the tangent of 45 degrees. For this piece, what angle gives us a cosine of root 2 over 2? Well, it's going to come from our 45, 45, 90 triangle. So this is going to be the cotangent of 45 degrees. Looking at those triangles, what's the tangent of 45? It's 1. What's the cotangent of 45? It's 1. 1 minus 1 is 0. And then our last problem, number 40. It's asking to show how the inverse sine of root 2 over 2 plus the inverse cosine of root 2 over 2 is equal to the inverse tangent of 1 plus the inverse cotangent of 1. Let's do it piece by piece. What's the inverse sine of root 2 over 2? We just saw this. This comes from our 45, 45, 90 triangle. So the sine of 45 degrees would give us root 2 over 2. Same thing with the cosine. The cosine of 45 degrees would give us root 2 over 2. Well, when is tangent 1? Well, again, looking at that same 45, 45, 90 triangle, the tangent of 45 is 1, and the cotangent of 45 is also 1. So this problem was just asking you to show why those two sides are the same, and we just did, because 90 is equal to 90. So stay tuned for the second part of this lesson.